big box of electronic gadgets from Google, and they said, we want you to do a program and build some cool things and invite some kids in to play with the stuff that you guys built and learn a little bit about electricity. So that's what we're going to do today. And the theme for this week's Maker Camp is music. So we had to build some musical instruments, some musical gadgetry, and we're going to take a look at that. But all of them were based on electronics. So what we're going to do today is make music, but we're also going to learn a little bit about electrical circuits, conductivity, insulation, resistance. Have you heard these things before? Now, electricity, electronics, the things that we use to build these cool things, it's all based on the flow of electrons through a circuit. So that begs the question, what is a circuit? What shape word does circuit sound like? Circuit. That's right. Yeah, so a circuit sounds like a circle. Basically what an electrical circuit is a loop. It's a loop of conductive material, and the electrons flow through this loop, just like you see in this picture. Basically, electrons like to flow from positive to negative. See, there's a plus on one side of the battery and a minus on the other side. So all those little electrons are flowing from the plus to the minus. But in between is where the magic happens. In between, you can put lights, you can put a toaster. Everything that runs off of electricity has a current flowing through it, flowing through a circuit, and that would, you can think of it kind of like a garden hose. If you had a garden hose, things flow through what flows through a garden hose? That's right. And if you hook, what do you hook up to the end of a garden hose? To water your grass.
Sprinkler.
Sprinkler, that's right. Or a slip and slide, or a sprayer, or lots of different things. But the water flows through, and at the end of it, there's something, a tool, some sort of tool, that does something cool. Now, the neat thing about a light, or in our case, musical instruments, is without these, electricity is pretty much invisible. You can't really see it flowing through the wires. But the wires are important because when I'm using my garden hose, if we keep thinking about our garden hose, you turn on the tap and the water eventually makes it to the slip and slide. Now what carries it to the slip and slide?
The hose?
Right, the hose. If you didn't have the hose, what would the water do? It would just spray everywhere, right? It would just leak all over the place. It would make a big mess. So you need something to carry it from one end to the other. Electricity is very, very, very much the same. You need something to carry these electrons from the battery to the thing that's going to do something, the tool, the light, the musical instrument, speakers, computer, like I said, anything. But the thing that makes all of our electrical tools work is conductivity. It's those electrons rushing through our garden hose. But not everything is a conductor. If you're playing a video game, yeah, what is attached to your controller if it's not a wireless game? A wire, right. The electricity has to flow through the wire. And it flows through the wire because the wire is conductive. And what's it made out of?
Rubber.
Rubber on the outside, that's right.
Copper.
And what is it on the inside? What?
Copper.
That's right, very good. Copper is one of the best conductors. In fact, when we were building, when you come up here, you'll see we actually used copper on one of the things we built today because it's such a good conductor. It's one of the reasons copper is so valuable. It's because it's such a good conductor. So, but what about, there's a lot of things that are conductors that we don't think about. What about a banana? Is a banana a conductor? We'll have to see. Let's check. Mary Ann's going to come up and she's going to show you guys. You're going to do some experiments and see if you can figure out what the conductor is, because here's the neat thing about conductors, your video game controller. When you have, before you push the A button, you're not making a circuit. When you push down that A button, you're making a circuit. And that causes something to happen. What happens when you push A? The guy jumps or something happens, right? Yeah, or you get a turbo and you're right, it shoots, or you get a turbo in your car or something like that. And that happens because something on the bottom of that button is a conductor. And when you push it down, it completes the circuit. So before that, there was a circuit like this with a hole in the middle. And your guy wasn't shooting. And then you pushed the button down, it completed the circuit, and something happened. So what that means is we can use conductors to make things like buttons and keys and things like that to control the flow of electricity. So what we did was we built an electronic piano. And you guys are going to learn about the different conductors you can use to play that piano. So I'm going to switch places with Mary.
Wow. Who wants to test it out to see if the bananas? Okay, you can go first.
Do you just touch it?
Yes. You gotta touch this ground first. And then
Complete the loop.
touch the, use your right hand and touch the, see if it. So it seems the banana is a conductor.
Ah. What is it?
Insulator.
That's right, an insulator. So, if something isn't a conductor, that means that it won't allow electricity to move through. It won't allow the electrons to move around. But let's go back to our hose. We know the hose itself is a conductor of water. It conducts the water through the hose. What happens if we tried to, instead of hooking up a hose, we hooked up a hamburger?
It would fail.
It would fail. No, a hamburger is not a conductor of water. It is an insulator. At least until it got soggy and gross, the hamburger would insulate the sprinkler. So the same thing happens with electricity. We have insulators and we have conductors. Now, a conductor, like copper, something really good like copper, that lets 100% of the electrical current through. A good insulator, like what was our best insulator up here? This guy maybe?
Yeah.
The plastic?
No.
Oh, what was the other one? The Lego? Yeah. Neither one of these worked very well. This blocks 100% of the electricity. But there's one more thing we're going to talk about today. It isn't quite a conductor, and it isn't quite an insulator, and that's called a resistor. So, a resistor is something that just lets a little bit of electricity through. It doesn't completely block it, and it doesn't completely let it through. It kind of like, if you look at that picture, it's kind of like if our garden hose, if we were to squeeze our garden hose, there would still be some water coming out of the sprinkler or the slip and slide, but not a lot. So that would be resistance. And you can also think about resistance as if you had a hose that was this big, how much water would go through? A ton. If you had a hose that was like this, there would be a lot of resistance. Yeah. There would be a lot of resistance. And electricity is the same way. There's certain materials that can resist the flow of energy. But the neat thing is, much like we were able to use conductors to control the flow through our piano, we can also use resistors to control the flow. For example, there are resistors that are sensitive to light. There are resistors that are sensitive to sound, temperature, let's see, what else? Lots of different things. But you can use resistance to control a circuit. So the second experiment we had was we built something called a theremin. Do you know what a theremin is? Have you ever heard of a theremin? And both of those guys are playing a theremin, and basically what a theremin is it's a musical instrument, and when you move your hand in front of it, you control the amount of resistance in the circuit, and it makes really crazy sounds. It makes sounds like this.
Ow. That was making noise.
that's our theremin. And what that does is, it has a little resistor, and when I get closer to it, it restricts the amount of electricity and makes that pitch go really, really high. It gets really, really annoying, really, really fast. And when I get further away, it lets more electricity through, and the tone goes lower, and it's less annoying, although still kind of annoying. And so, I wanted you guys to come up and play with the theremin a little bit. The other thing we can do is control the pitch. But hold on one second. Let me show you guys where this photo cell is. It's this guy right here.
Ooh, robotic.
So you're introducing resistance to that circuit. All right, make sure everybody has a chance. These are different kinds of resistors. These you actually have to touch them to control, and as you turn this, that's another way of controlling the resistance.
Let's do another one.
If you guys make it the loudest, you'll see it in the strap in the next
I got it.
Ooh. Messing around with clothes, huh? I'm trying to figure out
That's
yesterday.
We can play again in a second. But everybody have a seat. I'm gonna ask some test questions. Pass out some treats. That's what these are. So everybody's gonna get a battery, and they're gonna get an LED light.
Do it.
And what you're gonna do with this is you're gonna make a very simple circuit. Okay? This is a battery. That means it's got a plus side and a minus side, and the pluses really want to go see their friends, the minuses, and hang out. But they need a wire to get there. And so what you're going to do is you're going to hook up your battery and complete the circuit. Now that would do it. And the other and this is where electronics starts. And all of this stuff inside the circuit, you could, if you really wanted to, you could put a switch on one of these two wires, and that would allow you to turn the light on and off. Or you could put a button. In fact, you could even think of this in some ways as a button. Okay? And when I tap on my button, beep, beep, beep. So that's where electricity starts. So,
It is.
Okay. Oh, it seems like it is. Hit it again. There you go. And you can touch the banana too if you want.